So in this video we're going to quickly look at alkene stereochemistry. We're going to talk about the cis and trans designation. So what is stereochemistry? Stereochemistry just simply talks about the 3D orientation of any particular molecule. And so the reason we can have cis and trans isomerism is because the double bond here is locked, right? Once the conformation is set, it doesn't change unless it reacts or unless you do something to it to change it. And so that 3D orientation of that double bond is set, and it's either going to be cis or trans. And one important thing to note is that this particular convention only applies to di-substituted double bonds, so double bonds that have two substituents, right? If an alkene, right, if you notice it, this is my double bond. If an alkene has two substituents and both of those substituents are on the same side, we call it cis. If an alkene has two substituents and those two substituents are on opposite sides of one another, then we call it trans. An easy way to remember this is to think TOS, right? TOS, trans, opposite side. So if the two substituents are on opposite sides of the double bond, notice here's my double bond, here's one substituent here, here's the other substituent here. If they're on opposite sides like that, then the double bond is trans, right? An easy way to remember cis is CSS, right? CSS, cis, same side. So if the two substituents are on the same side of the double bond, keep in mind this is my double bond and these two substituents are both on the same side of that double bond, then the alkene is what we consider cis, right? The best way to illustrate this is to do a little bit of nomenclature. Again, we're not going to go into great detail with the nomenclature until later, but let's do a brief introduction. So you remember when we previously talked about nomenclature, about the chain lengths and the parents. So the convention is to find the longest chain that contains your double bond. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. So the parent is decene. All right. Here's my double bond here at the beginning, and so the name of this compound is 1-decene, where 1 tells me the position of the double bond. Right. I start counting at the end where the double bond is closest to. All right, so this is 1-decene. Let's look at another example that's a little bit more involved. All right, still 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. And if you still have trouble with skeletal forms, take a pencil, draw this out, and put a dot at the end of every line, which will be here and here, and put a dot at every vertex to help you understand where those carbons are. All right, so here's my double bond here. And so the name of this compound is different. So let's look at what the name is. The name is trans 5-chloro 6-methyl 3-decene. All right, let's go through the name. The 3-decene tells me the location of the double bond. If I begin counting on the end closest to the double bond, this is 1, 2, 3. Right? So at carbon 3, that's where my double bond begins. So the location of my double bond is shown by the number 3. All right. The trans tells me the orientation of the double bond, whether the two groups attached to this double bond are on the same side or on opposite sides. We just saw in the previous slide that trans means that the groups are on opposite sides. So this double bond, one group is here, and then we can see that the other group here is on the opposite side of this group. And so this double bond is trans. So we have to include the stereochemistry in the name. So trans 5-chloro, right? You can see 1, 2, 3, 4, 5. Chlorine is at carbon number 5. And then 6-methyl 3-decene. Why chloro before methyl? Because you list your substituents in alphabetical order. So let's look at this double bond. You can see right away that there's something different about it, right? Here's my alkene. Here's my double bond here. And when we look at this double bond, you notice that it's different, right? And actually what's different about it is that the two groups here and here are on the same side. So this double bond is cis and not trans. So the name of this double bond is cis 7,9-dichloro 3-decene. So 1, 2, 3. Again, that's the The 3 is the location of my double bond. Dichloro, remember, if we have two substituents that are identical, we use a prefix for them, and the numbers are just where those substituents are located. Remember, the parent is the street name, the substituent or the resident is here, and the address for the resident is here, right? Set 1 chlorine stays at 7, the other one stays at 9. So this is cis, right? That's the orientation of my double bond. Both groups on the same side, 7,9 dichloro 3 decene.